Welcome to this year's FMX. It's funny to see sitting in the rows are many people who are here every year or have met on other trade shows. It's nice to be here in a family together, looking what we can do in Cinema 4D. My name is HMaus. For these people who don't know who I am, I'm a trainer for 3D and visual effects software, mostly Cinema 4D and some other cool stuff. But I also train Maya and Houdini. And on the compositing side, I work with Nuke and After Effects for broadcast clients. And there are some great tools out there which I also train, which are RealFlow, for example, or Vue, if someone knows what Vue does, landscaping. And in this little presentation this year, I want to show you, additionally to Cinema 4D, RealFlow. And the question arises, why RealFlow? Cinema 4D has simulations, you can do all crazy stuff in Cinema 4D, and there are plugins out there for Cinema 4D. And so I try this year to make a connection between these two tools, and I try to give you some impressions why this tool makes sense to you. So if the guys here switch now, I will begin with a official presentation. I worked all night for this wonderful slide here, you see. Okay, and the first thing we have to do is I want to show you why Cinema 4D. And this is the trailer. So let us have a minute for Cinema 4D stuff. Maybe you have seen in this trailer that Cinema 4D has shaped a little bit of its profile. If you started with Cinema 4D some years ago, we had Cinema 4D very strong in the broadcast market. And most of the trailers you saw were typical broadcast trailers. And meanwhile, if you have taken a closer look here to the trailer, you see suddenly that more and more visual effect stuff arises in these trailers, because Cinema 4D is a very capable tool of making visual effects. I sometimes tell my clients that Cinema 4D is capable to be a small TD tool for technical directors, because Cinema 4D is very easy and it has a wonderful range of now plugins which you can use to extend the range of the features of Cinema 4D itself. But Cinema itself has some limitations. But take a closer look. If we work in Cinema 4D, we have a really nice and stable rigid and soft body simulation. It's based on the Bullet engine, you know this, and the Bullet engine is production proven. We have a nice implementation. We also have added some really cool stuff, like for example, motor engines, and we have some nice other tools added, which I will show you in a moment. Then we have a cloth simulation. I know Clotilde cloth is a little bit older, but it still works. It's still working. You can do amazing stuff with it. We will take a really short look into it. Then we have hair and fur, and additionally architectural grass simulation. And this is also something you can use a lot in visual effects, because if you need, for example, a spline renderer, a spline, a hair, are really similar. And so you can use hair renderers for splines, for example, to make flying lines and all this crazy stuff you saw in the trailer. And we have a standard particle system. I don't tend to use it a lot because it's very, very limited. But we have thinking particles implemented. To make this here clear, thinking particles in Cinema 4D is not equal thinking particles, you know, for example, in other tools, because our thinking particles is a little bit older from the core, but it is increased a little bit in the feature size through Maxon. So it's a little bit different, like the thinking particle you know from other tools. And you can address this particle system, which based on groups, rules, and you can set up really amazing stuff with Espresso, our programming language we have in Cinema 4D, without coding one line. It's really nice. You only have to make a noodle soup. You have to connect ports with each other in a logical way. So this is the setup we have. And like I've said, I use Cinema 4D a lot for visual effects because it has a nice plugin infrastructure. And plugins for Cinema 4D are sometimes free, very often free. You get awesome stuff. For example, if you know the website Nitro 4D, there's a funny Greek guy who's making amazing stuff, mostly for free. And the commercial products of him are amazing cheap. So you can get, for example, Catastrophe or, like I've said, Nitro Blast for fracturing stuff for some dollar. It's extremely cheap. So really cool. But there are two plugins which I want to show you a little bit more in particular. These are Turbulence FD. Turbulence FD is solver for everything which is based on gas fluids. So if you want to make fire, if you want to make smoke, or you want to have a crazy plasma or something like that, Turbulence FD is extremely capable. I will show it to you in a moment. It's not meant for making liquids, so no water simulations in it. It's all based on gas in the moment. And we have another wonderful plugin here for Cinema 4D, which is named X-Particles. It's now released in version 3. And X-Particles is the particle system you only want to use, because X-Particles is extremely powerful. You can do everything without writing one line of code and one Espresso setup. It's really easy. It depends on questions and answers, or questions and actions you can do with it. So you can do crazy particle simulations. In earlier versions, you only were able to do these particle simulations in thinking particles. Now you have another particle system which is multi-threaded, and yeah, it's really great. You also can make trails. Trails are something like that. Here in the head, you see I've traced the particle movements through space with a trail, and this here is rendered with hair. This is something I want to tell you in the earlier stage. The hair renderer of Cinema 4D you can use for rendering splines, and that's exactly here done. And yeah, and you have two systems. I don't know if you know these little funny names. SPH is a particle way of calculating fluid simulations. We will see this in RealFlow in a moment. And you also have a flip solver in it. In RealFlow, it's named Hybrido. It's not equally the same, but yeah, it's like Hybrido, so you can have full containers of fluids moving around. And this particle system is also capable to rendering or simulating these two kinds of simulations. So this is a little bit what we can do from the cinema side for ourselves. And I want to show this extremely quick to you. So we switch here to Cinema 4D. I hope everyone has seen Cinema 4D before. Yeah, so this is a cool program. You can use it. It's a 3D package. Yeah, and I want to show you extremely fast these types of simulations. And normally, we at Maxon, we don't tell the people what we can't do. But this presentation is a presentation between two companies, Maxon and NextLimit. And so this time, I think I'm allowed to tell a little bit about limitations. Yeah, so okay. So let us start with the dynamic system we have. Rigid body bullet system. What is meant with it? Easy. If you want to do a dynamic simulation, for example, you take an object. Never use spheres in presentations. We have learned this, but everyone is doing it. Okay, so you have a sphere, and you have something you want to drop the sphere onto. For example, a wonderful plane here, and we say we want to have another one here. Rotate this a little bit around, and yeah, now we have a wonderful thing. If you ever make trainings, give the people the ability to play with simulations. You don't have to do anything the whole day, because they play the whole day. It's wonderful, yeah? We are back in the children's age. So, and to make now the sphere simulation object, you only have to make a right mouse button click, go to our simulation tags and say, this is a rigid body. It's a solid body, it has mass, it has structure. And these two planes, what are they? They have to be a part of the simulation, but themselves, they don't have to do something. And this is named a passive object, or here in Cinema 4D senses, it's a collider object. And if you press play, wonderful, I've finished, and now you play the whole day, you have your first simulation, wonderful. Yeah? So you see, rigid body simulation we can do in cinema without any problems. It's really easy, like a children's play. If you look into the tags here, you see you have all the stuff you know from school or not know from school. Yeah, you see things like, for example, what mass you want to use. In the moment, every object is in world density. That means every object you have in your Cinema 4D has the same density, and the size of the object says which weight this object has. And yeah. But you can change here nearly everything. You have here the way how collision is calculated. So you know from school, collision is always between two objects. If you have a tire, which is made from rubber, and you have a street, between them you have a collision. That's a good thing if you try to drive. Yeah? But there's also forces between them which are named friction. You know, rubber has a higher friction value, so your tire is nice on the street. But the problem is, if the street now is icy, the rubber doesn't have an effect anymore. Yeah? So be careful if you drive. And so this is the thing, two sides. The rubber hasn't changed. Yeah? The friction of the rubber is still high. But if the street is low in friction, yeah, you have a problem. And so you have to tell every object in the system which friction, which bounce, which energy comes back, and you set all the settings, the weight, and then you play and play and play the whole day until you see exactly what you want. There's one thing you have to keep in mind if you ever do simulations in a 3D program. Don't let the things simulate all the time. If you have finished, if you have found something which you are happy with, you have to cache it or bake out it. Don't send it to a render farm, because every time cinema steps into a frame, it resimulates. And all simulations are a little bit random. That means if you have a team renderer and you have 5 machines, every team renderer machine makes its own stuff. Yeah, that's wonderful, but it doesn't help you in the rendering because, yeah, sometimes the sphere is there and there and there. So to cache this out, every of these tags has a cache here, or you can press Command or Apple D, go here to the dynamics and go here to the cache, and here you can bake out all the stuff. And if you have baked it out, it's like a file, and then you can scrub around here and everything is fine, you're happy with it. And then you can send it to the farm and do other crazy stuff. So, rigid body. What is a soft body? A soft body, we have to delete the cache here and don't use the cache data anymore. I go to the sphere and I want to have a soft body. In Cinema, it's implemented in the same tag here. You now tell the system, okay, I want to have a soft body. I want to have it based on polygon and lines. And if you ever make soft body simulations, it's working like this. Every point in the 3D object has a connection to the next point, and these connections are like, what's the name in English for it?
Spring.
Thank you. Mr. Nose Man. Thank you. Springs, exactly, and you know how springs work. You can compress them, you can they always try to get back into their original length. And that's the way simulation here works. And if you take a closer look here, you see a problem in most simulations if you make ever soft bodies in Cinema 4D. You see that the ways between the points are very different. So that means if you have a spring which is extremely long and a spring which is extremely small, they behave different. So this ball doesn't work completely equally. Yeah, the poles are working in a different way. So if you try to ever make soft body simulation, try something where you have a very equal distribution of springs. And something like that here makes it easier. And you will later see that if we go to RealFlow, RealFlow likes triangulated meshes. And that's one reason for this. Yeah? So you see, make equals springs. And if you now press play, you see, bloop, we have our soft body. So, looks a little bit funny. Okay, wonderful, soft body. Caching, same stuff like before. You see, this is something we can do in our system. Like I've said, we have other crazy stuff here which we added to this kind of simulation. You find it here in the menu. It's connectors, springs, and force and a motor, engines. So it's extremely cool. You can build cars, helicopters, and all this stuff with this system. So why we want to use another solution? If this solution is so capable. Sometimes we have a problem because now I want to add something like, for example, cloth. Cloth we can do. Cloth is extremely simple to do in cinema also. Everything in cinema is simple, you know. Okay, simple but capable. That's, yeah. If you want to use this here as a cloth, I name it so that we can better see it. And we want to make a cloth, it's easy. Go here to the simulation tabs and say here, this here is cloth. And the next thing you have to do, it's an older system, you have to press the C key for converting it, because cloth only can work with polygon objects. And if you press now play, the cloth says goodbye because gravity, cloth goes down. Yeah, it's a little bit a sad thing. But what we can do here in the cloth, we can go to the points mode and tell the system, I want to have these points here, these points, and some here in the middle. Yeah, it's not the nicest cloth, but you understand the way. And then in the cloth tag itself, you can tell a little bit the cloth, how it works. You see here typical parameters of cloth, stiffness, rubberies, and all this stuff. The forces, the gravity, and you see here is a different gravity than the main gravity of the bullet engine, which makes later a little problem for us. And you also have here the cool thing like dress-o-matic. It's extremely cool. Dress-o-matic means it shrinks your cloth until it finds something to collide with. So you can use it for clothing a character, but also for things like wrapping up stuff and so. And here you can now tell the system, I want to fix the points I've selected in space. And if you fix them and press play again, simulation always from the first step, you see now the cloth is hanging around and everything is fine. So cloth itself works. You can interact with the cloth extremely easy. If you go here and say, I need an object which is interacting, for example, this wonderful sphere, but now comes the first limitation. We have here a wonderful simulation running. But if you want now that this simulation here and this simulation interconnect, we have a problem because you first have to bake out this here. We cache it, like we've seen before. And then we say this object is a collider for the cloth. Yeah? Or I have to make a new object which I parented under the other thing or so. But you can't calculate both things at the same time. You see, this here works, the other thing works, but there are two different systems. And these two different systems, you always have to decide what comes first and what comes next. Yeah? So, no interconnectivity between these. The next thing is the hair system. I don't want to show it now the complete hair stuff, but it's the same. It's a different system. Yeah, so you have a hair simulation. Really fast hair is, for example, if you go here and make a HMaus spline. HMaus splines are always cool because they are so round. Yeah, round splines are always nice. Select all the points. Go here, and here's a nice function to make a little bit more points. It's named round. And if you say, I want to have a schema, 20 points, apply, you see you have now 20 points. And the cool thing is you can say how many points you want to have. Because the simulation can only bend something at the points, not in the segment between them. So you need many points. And if you now want, for example, to have this here with a hair idea, you have to go here in simulations. You don't have hair. Why? A different system, like I've said. So you have to go here to the hair tags, and here you have to say, this is a spline dynamic, because I want to have a spline behaving like a hair. Now it does the hair thing. You see, goodbye. It falls down like every hair. But then you can also fix a point here in the hair. For example, if you go here and say, okay, I want to be in the points mode, look around, find a point which you are happy with, for example, this here. You go now here, and fixing here is a little bit different. If you go here, you have here constraints, for example, where you can fix a part of a hair to another object, or you can say, yeah, I only want to fix it, it's not important where, it's only fixed in space. You click here, fixed, and then if you press play now, you see the hair hangs around. It also can interact now with the other simulations, but like before, you have first to bake out the other stuff and then say, okay, I need a hair collider now for this simulation, and then you do it. So this was a really fast run through the simulations we have with rigid, soft bodies, hair, cloth. But you see, we are capable to do something, but interconnection is a problem. And this is solved, for me, externally through RealFlow. And so we can go back here to my little presentation here. So the question is, why RealFlow? So, yeah, first thing, it's specialized. RealFlow is a specialized application for doing fluids, different kind of ways of fluid solving. It has a full soft and rigid body simulation. So the terms you now learned from cinema, you will see the same terms in RealFlow again. You have SPH particles. Now comes the point, what are SPH particles? Every particle is a little part in space, and it has an age, for example, a weight, for example. It collides somewhere. And you can think about a SPH particle that all the informations are stored on a particle, and they interact with each other. And the cool thing here is that the SPH particle system is very easy to direct. You can say, okay, I want that my particle do this or that. It's extremely easy. And so RealFlow began with SPH for making fluids. Yeah? Because if you have enough particles and they behave like a fluid, you can mesh them, and then you have a fluid, but you can direct them. You can say, okay, I want to have the fluids pour into a glass. It's a typical thing. I want to have an extremely realistic fluid simulation. I want to fill this glass. But the fluid has to make a hard form or hard shape while it's going into the glass, fully realistic. And then you see SPH is capable. You have Hybrido. I will show it in a moment. Hybrido is for large-scale simulations because SPH is not capable to do extremely large-scale stuff, not because SPH has the limitation, but your memory and your render power has the limitation. So SPH is good for small stuff, for splashes, for filling something up, for interaction between particles, but not for big oceans and big ocean scenes. SPH is not the best thing. So Hybrido is there. And then we have a wonderful technology, I think, it's named RealWave. You will see it in a moment, where you only make a water surface. You don't think about particles, you don't think about volumes you have to work with. You only think about the cool waves, about interaction between surface and something else. And you have fracturing. And fracturing is needed if you want to destroy something. No one wants to destroy something, but if you need, you want to hit something and it falls apart, you want to have fractures, then you can use fracturing here. So, this is the last slide, and this slide says all simulation types, or mostly all. I don't say all. There are some limitations also in RealFlow. But the most simulation types are connectable in RealFlow. So you can now have a soft body simulation combined with particles, combined with something which looks like cloth, combined with water, for example. And this is something which makes RealFlow extremely strong now. It's available for all platforms, all major platforms, Windows, OS X and Linux. It's easy to have a connection with it, you will see it in a moment, and it's easy to learn. And this is something we are used to in Cinema 4D, and now you have another application which is also easy. And let us take a small look, and then we go into the software and play a little bit together. Okay. Let's step into RealFlow. The first thing you have to know if you ever go to RealFlow here is you need a project. Without project, nothing works. And for this purpose, I select here now a path where I want to place my stuff. You see RealFlow Play. It's a good folder for it. And name it somehow. Cool01. Cool name. And create a project. RealFlow has an interesting system of projects. You see, if you make a project folder, you get something like that here. You see a project file, which is the RealFlow file. And then you have a whole bunch of folders now. And in these folders, you later get caches. And these caches, you know from cinema, caches are important because you can do it over and over again what you saw. And RealFlow uses these folders a lot. And these folders will have enormous sizes later. So be a little bit aware that normally in production you don't use these folders here on your main hard drive. Otherwise, overnight, sometimes you can't work with your computer anymore because your hard drive is then full. So yeah, make it externally. And so we have done this. We can now go to RealFlow itself. This is the interface. You see, it looks extremely easy. Yeah, it's very clear, no clutter around, so really fast run through. You see here you have shelves. And the nice thing in 2014 was that we can build our own shelves here. So if you make a right mouse button click, you can edit commands, you can remove something from the shelf. You can also go here to edit shelf, and you see this wonderful shelf manager here where you can make your own shelves. You can look in the cool stuff you have here. And these are all the things RealFlow is capable to do, which you find somewhere in the menus, and you can add everything to your shelf, but also your scripts. RealFlow is scriptable. You need it some time. For example, you want to have an emitter at a hit point of something else, and then you can script this, and yeah, you can add your scripts in your shelves, and so you have your own environment. So really easy. Same for shortcuts. In these shelves, you see the first tools we normally use. Like I've said, we have particles, liquid particles. These are the SPH stuff I've told you. Normally you have a whole bunch of emitters. You want to emit particles in the system. And then you have the daemons, geometry. You can make some geometry stuff here, but you are not able to model really in RealFlow. These are more like stand-ins. If you really want to have models for RealFlow, you have to import them. We will look at this process in a moment. But here are some primitives which you can use, so important ones like rocket and all this cool stuff. Yeah. Then we have at this side here selection tools and movement or translation tools. They are the shortcuts from Maya. They are a little bit different from Cinema 4D, but nearly. So if you have a sphere, for example, you go here, you press here the W key, you get here a little translate widget. If you press the E key, you get a rotation, and the R key is scaling. So it's a little bit turned around from Cinema 4D, but yeah, you can change the keyboard shortcuts if you really need, but you get used to. It's not the problem. Yeah. These are these tools. Then you have here something which is, in the first place, a little bit annoying because, yeah, RealFlow users use this a lot, but sometimes you don't see what they do in this moment. You have here something, you can make something invisible with these two buttons. So if you select something, this makes the object invisible, this visible. This is important if you have a domain, for example. You want to fill, for example, a pool with water or with particles, but you only want to see the fluid, but not the domain which you've built. Or you need an emitter for hybrido, which is always a geometry, but you don't want to see the geometry. You only want to see the particles. And so you say, hide them for me. So you really often see that you click here and you hide something. And this is the shading. So this is the shading for every object you can select. There's a shading for the full scene. You can use here the number keys on your keyboard. So if you normally use here 8, 9, or 0, you see the shading for the whole scene changes, but you also can make this on an object base. If you go here, this is a bounding box, wireframe, shaded but not rounded or not fonked for cinema users. And here this is now wonderful fonked now. Yeah, and this is for working with the caches, so you can cache something out. It's really intensive, and then you say, please only read this object from the cache the next time I run. I don't need to resimulate this object in the moment again. That does make sense. Okay, this is really fast about this part. This is the message window. RealFlow talks a lot with you. Yeah, and so it's important for RealFlow that it has a message window. Sometimes you see errors here or warnings which you can ignore. You will see some in a moment, yeah, but sometimes it's really useful to read what RealFlow wants to tell you. If you now build a scene here in RealFlow, I bring this over and say also I want this rounded. Here you have your nodes, and these nodes here tell you which objects you have in your scene. You can select here the objects, you can rename them, and yeah, you have then at the right side here the node parameters. It's like the attribute manager in Cinema 4D. So if you want to tell the sphere something, go to it. Here are things in the node tab, for example, where I am, which rotation, which scaling, which color I have here in the viewport. And most important here, these two options, do I simulate in the next simulation pass? This is named active. I'm not reading from the cache. I'm really an active object in the moment. And do you want to have a rigid or a soft body dynamic on the object? It's really easy. It's only to say here, oh yeah, I want to have it. It's an active object, or it's a passive object. It's like the collider in Cinema 4D, or I'm a soft body. And one thing you have to keep in mind, if you select something here, I want to show it to you a little bit clearer. You see here new tabs appear. So really often people search for parameters, but they haven't switched something, and so the parameters don't arise. So if you want to have, for example, a rigid body, and you tell this, then you get a whole tab here with rigid body settings. Otherwise, you don't see them. Okay? So this is a little bit about this interface here. Then there's here a nice addition in 2014, which I like a lot. If you have RealFlow in an older version, I started really early, and it was a little bit complicated because sometimes you have simulations where you have to tell, okay, this object here is touched by gravity. This object here you don't want to touch with the gravity, and this object here has a different kind of gravity. And in earlier things, you had links, fields, external links, internal links. It was mess. Yeah? You had to make a script first on a sheet of paper and decide what you want to do, and then do it in one step. Yeah? Otherwise, you don't understand it anymore. This is now wonderful in the relationship editor. You see exactly who is interacting with who. That's extremely nice. Yeah, you see there's a hub. Hub is like a connection for all stuff. You can have as many hubs as you like. If you have here, click another one, you have another hub, and you can connect stuff together. You can draw lines between stuff. I want to demonstrate this really easy. I connect these two, and I go here, and I tell the system both objects here are in the moment rigid bodies. So normally rigid bodies in Cinema fall down. If I press the A key, you always have to simulate. They do nothing. Why they don't? The problem is they don't have a gravity. And if you need forces, gravity and all this stuff, this is named in RealFlow with the name daemon. A daemon is like a force, sometimes an idea you have to do. And here are little daemons you can use, and here's a gravity daemon. And if you click this, you get a new object here. You can place it somewhere because this gravity is everywhere, so you don't need to keep in mind where it is. And if you now resimulate, you see goodbye, they fall down. Yeah? The same thing like before. Because this gravity connects with the same hub like these two objects. So, same system. And now you can go in and say, okay, I don't want this. Select this line here and say goodbye. Yeah? And now the gravity does nothing because it's not connected. And now you can decide, what I want to do. For example, you can hold down the Control or Command key and say the gravity only works with the torus. You see? It's really easy to understand. And if you go here, now the torus falls down. Okay? Other idea would be if you have more objects. I go here to the geometry and say, now I also have a rocket. Wonderful. And this rocket is also connected to the hub, but the rocket does nothing. But if you only want to have one guy who doesn't do something with the gravity, you connect this gravity daemon to the hub, and then you say, okay, the rocket doesn't fall down. You remove this from the hub, and then you press simulate, and you see. So in most cases, you see a whole bunch of relationships. You have a whole script with relations of daemons. You can have more than one connection. If you have, for example, a really big scene, you can go in here and say, okay, I have another hub here, and this object is connected to this hub, and now I want that this gravity works with these two hubs at the same time. Yeah, you see, it's really easy to understand these relationships. So, you see, all the time I press the A key, you always have to simulate. Simulation means that you now go in here and you get this yellow line here. And this yellow line means these frames are now cached. And these caches are placed here in these folders. And if I open this up here under Objects, you see for every frame you get a cache here. And you get a SD file. And this SD file is really important in the next step. You can decide in RealFlow what you want to cache out. And for this purpose, under Export, you have an Export Central. And in this Export Central, you tell all the stuff RealFlow is able to do what you want to write out. And now we have 3 objects, rigid bodies, and you can tell now what you're interested. There's a full animation cache of all objects. You see, the objects are cached in the animation SD. So all the stuff of the objects are placed there. But you also can go in here and tell, for example, the sphere, I want a separate cache only for the sphere. It can be a SD file, which is a RealFlow special thing. You need a RealFlow plugin for it. We'll see in a moment. But there's also the ability for an ABC file. An ABC is something which is the industry standard. It's a polygon cache, which we use a lot in visual effects. Yeah, Cinema is able to read and write it. Maya is able to read and write it. Nuke is able to read and write it. Houdini and all these cool tools. It's only geometry, so no shaders or things like that. But you can tell now the system write out an ABC file, and then you can place another solution. Also, RealFlow is capable to read this. Like I've said, also Cinema. Then you can also, that's nice, in a moment you can also write out Arnold files. It's really nice, so you really get S files, yeah? And then you can send them to the render server. You know how the render manager of Arnold is named? Kick. So you have to kick. Yeah, okay. So you can write out everything here as a cache. You have to decide what you want to have and so on. Okay. So I go out here, and we want to do now something productive. So I remove a little bit of stuff. And the first thing I want to show you here is extremely fast, rigid, soft body, something stuff. But this time I want to come from Cinema. So how to get your cool cinema stuff, you're a cinema artist, to RealFlow now? Wow. I haven't modeled too much in the moment, so I have to search here on my hard drive. This is the most dangerous part of an artist. Do I have something? Yeah. There's a sculpted apple, wonderful apple, and I want to bring it over to RealFlow. And there are now different ways of doing it. First thing, you can have an OBJ export. I know cinema, OBJ, no problem with RealFlow, but one thing you have to keep in mind. If you make a direct export for RealFlow, you have to triangulate an object. You see it here. These are all triangles. If you forget this, RealFlow is not able to read this stuff. In cinema, triangulation is easy to do. If you have an object which is not triangulated, make a polygon object out of it, go to the mesh menu, go to the commands, and here you find triangulate. And if you do this, you get these nice triangles, and then you can export this object as an OBJ. RealFlow is happy, we are happy, everything works. Okay. The next thing you are able to do, Cinema 3D understands, like I've said, Alembic. Here's an Alembic export. You can export your whole animation. It's baked out in the moment, and you can read this into RealFlow. But keep in mind, Alembic is a cache. It's not an export format. It's a cache. It's like the database. So if you export something to Alembic, all other tools have a direct connection to the Alembic file. And they read every frame. If you scrub, he reads. And so you have some limitations in changing stuff, for example, in RealFlow or another application, because it's reading in every frame. And so, yeah, you have to keep this in mind. So this is one way of doing it. And the next thing, or the best thing from some cases in production, is you go to the plugins menu, and if you own RealFlow, you have here RealFlow connection plugins. And you see, you can export particles from Cinema 3D. You can export SD files, the scene description file, which we saw earlier, which RealFlow internally also use. And we can have meshes exported. And an important thing you have to keep in mind in RealFlow SD export is you only are able to read one SD file per scene in RealFlow. So if you have more than one object now, and you only want to use one of these objects in RealFlow, you have to make separate SD files. Otherwise, it doesn't work. If you otherwise delete one object in RealFlow, the whole SD is gone, and you see nothing anymore. Yeah, so keep this in mind. So if you want to have now the apple, you can say, I want to have the apple. This plugin looks through the whole folder, what is inside. You want to have the apple, yes, add it. You can select what you want to have, where you want to store it. So I go here in, I say demo assets maybe is fine. I want to have an Apple SD here, say save. And now you can see how many frames you want to write out. This apple doesn't do anything. So one frame is absolutely okay. Yeah? But if you have an animation, for example, you have a driving car somewhere going over the street, and then you decide, oh, now I want to have nice splashes from RealFlow, then you can cache out with these options here the whole scene and bring them to RealFlow. So you don't have to think about caching here. So I say, okay, I want, for example, only one frame. I say export. It's a really fast thing. And if you now go to RealFlow, you can now go in here. This hub we don't need anymore. You go to import object. And all the options I've told you now are here in this folder. So I go here. I think I have it under my demo assets. Yeah. I want to have a SD file. You can have the Alembic file. You can have the full SDs and so on. I say now open. And now I have one SD file here in my scene. And this SD file now, I can't do anything with it because he thinks, maybe Helge has done something great stuff in cinema. I can't change this in the moment. So you have to convert it to a RealFlow thing. And this is made here by this name SD to curve. Yeah, so if you do this here, then you can play with your apple here like you want. Otherwise, it's fixed to the animation you've done in Cinema 3D. Yeah, now we can do here some stuff. We can make a plane and tell this object here it's active, yes, and it's dynamic. And you can say, okay, make it here, for example, a rigid body. We need some gravity. Gravity is always a good idea. And we have here a plane. And if you press now the A key, you see your apple falls down and says goodbye. But the plane has to be a collider. So select the plane, say, yeah, I want to have it. It's passive. Reset everything. Yeah, and it works like expected. This simulation, the rigid and soft body, is much more stable than in other applications. It's not so complicated to simulate here. But I wanted to make a soft body simulation. So I go here to the apple. Say here I want to have it 0. Go here, and this here is a soft body now. And you see it's a little bit slower because you have now a soft body, but it works like expected. Wonderful. Yeah. If you have finished your caching here you can tell the system how many frames you need, for example, 50 frames. You can recache. That's really funny. If you see something which you don't like, you say, until this point it was extremely great, but now I don't like it anymore. You can go with your time slider to this point, change something. Yeah, for example, now I want to have wind in it or whatever. Yeah, and yeah, make a little bit funny here. And then you can cache from this point. You see? He says you a warning. It says, be careful. Now you overwrite files, but you don't have to go back and do everything again. You can say, until this point, wonderful, and now I really want to do something else. And also you can key everything here. If you have finished now this cool stuff, you can go here to your folder and you will find here an animation SD, which you can re-import later. So this is a way of rigid soft bodies. I want to show you another thing. RealFlow is also capable for you to make particles. We have talked about this. And so we go here to the particle system. I take an emitter, for example, a standard circle emitter. And if you take this emitter, press the A key, wonderful, we have particles. It's extremely easy, yeah, to do. And if you look into the attributes of these particles, you see a density. And this brings me to the point physicality of RealFlow. RealFlow thinks in physical scales. One of these little grids here is 1 meter in reality. And this here means 1,000th the density. If you have water and you have 1 meter, a cube of 1 meter of water, you have 1,000 kilogram. And that's exactly here the density. So you can change here everything, but you have to keep in mind this is a scale. You can change the whole scale of RealFlow, and this is sometimes really important. Here under this scale options here, you can rescale your stuff. If you come from cinema and you see it's too big, too small or something, you can scale here your geometry without going in with the scale tool and do something, but make something which makes sense. Water behaves in small sizes different than in big sizes. So here you can change everything about this, but this water doesn't do anything. So we add now gravity, and you see these are the same forces I've used for the rigid body system, and that's the cool thing here. Not a different system. I go in here and now you see the water does what water does. It falls down. And now I can say I want to add something for this system, a plane for example, and this is a rigid body. And if I calculate now, you see I calculated from this point, you see now they interact now. This here also can be now a standard simulation. That means if I go now here and say, I have here a sphere, and this sphere here, for example, is an active rigid body, I deactivate the gravity for a moment, Yeah? And I shoot now out my water. Okay, that's always the same thing. Don't hit. You see suddenly the sphere moves. Everything is connected with everything. You don't have to cache one stuff out. You can use it at the same time here. Yeah? And that's a big point for me for using it. Yeah? So, you see, they are connected. These particles here are SPH particles. That means you can use a whole bunch of really crazy demons here, not only gravity. There are demons like, for example, the limbo, where you can bring something in a different space, where you have drag, where you can have noise fields. And one of the most used ones is D-spline. Like I've said, if you want to have a pour water into a glass, you want to supervise exactly where the water goes. So you can draw a spline and say exactly this path here. But this path is like a force. And so the particles go over this force and come into the glass. So these are the SPHs. Like I've said, for small simulations, they are great. The next thing we have here is named Hybrido. And Hybrido is for the big ones, for the big stuff. So if we go here to Hybrido, normally you first need a domain of it. The cool thing in RealFlow for me is you can have a closed domain. That's nice. Yeah, so you have a tank of water or something else. But you also can have an open domain, because sometimes you don't know how big your domain has to be. You have only an idea. So I say I want to have this domain. And if you ever made flip simulations, you know there are voxels behind this. And you see here the voxel size in the moment. But there's no container in the moment where this stuff belongs. If you now need an emitter, you always need here a geometry. I've told you this a little bit before. That means if you go now here and say I want to have a sphere full of water, you can make a sphere. You can say I don't want to see the sphere anymore. It's not interesting for me. But I tell now this is my emitter. And now I go here to the Hybrido stuff, and you see here you can say I want to have an emitter. And the emitter wants to have an object connected to it. So if we have now here our emitter, you have to click here and say which object you want to emit fluid. And I say this here is my emitter object. And if you do this, he asks me two questions which are important. Do you want to have a stream? So do you want to emit over and over particles, or is it a one-shot thing? Fill it and that's it. Yeah? These are the two things you have to decide. So no, I don't want to have a stream, because this here is a laptop. And you see, now I have my first fluid particles, Hybrido particles. They don't do anything, you know, you have heard it a lot today. You have to go here and decide for a force you want to use. And here I go in, make a gravity again. And now you see, goodbye, it falls down. You see, it's so easy. You don't have a domain before. It does it dynamically for your work. So a good idea are these kill demons here. I don't want to have particles which go extremely astray. If you ever have particles which go too far away, you have the problem that they are still calculated far away. You see, this is your first splash. And now you see there are particles going somewhere. It's a little bit dangerous, also for SPH particles. And you can use, like I've said, a kill demon. A kill demon has a very good job, because you can say, I want to have it here, for example, in scene size. This is the demon, the green box. And every particle which goes over the edge is killed. Yeah, that's the name for kill demon. And it's really good, so you don't calculate particles which go extremely away. So now you have particles in Hybrido. Like I've said, you can fill up stuff and all this. You also can interact with the objects, with the rigid bodies. Again, you can have something swimming. I hope I have some minutes now for the real wave, because it's a really cool feature here, which I think most people forget. Sometimes you only need a water surface, something which looks like sea, water, but you don't want to think about particles and all this crazy stuff. You only want to have water. Yeah? And for this, the real wave technology here is really cool. You click here and say you want to have a real wave surface. And this surface, in the first place, looks a little bit boring. It does absolutely wonderful nothing. That's good. And here you see in the surface itself, you can tell now how this water surface is calculated. And for this purpose, you add a wave or more than one wave. You can, for example, tell here, I want to use a fractal for this wave. And if you do this and you begin to simulate, now you see, okay, now you have a surface. It doesn't look exactly like water in the moment, but you understand the idea. Now you can go onto these options here, and in these options you can tell now the system which height your waves want to have, how fast, the seed, the speed, and all this stuff. And if you now do it again, you see you can make really nice surfaces. And if you go now here, you see different kind of formulas you can work. And there's one which is named Ocean Statistical Spectrum. Nice name. This is a waveform which you can tile. So you can make a small part, a nice wave, and then you can say, but I need an endless ocean. And then it's tiling this formula so that you don't see the cuts between them. And this surface here now, I have to come to the end. Yes, I know, thanks. You see, it's always the same. I start too late, I have to end too early. You see now here, this is the surface, and to end this, so the other guys have their time, they interact fully with the rigid bodies. So if you ever need something falling into it, you have to say it's a rigid body, you need a daemon like before, that it falls down, and then you have only to keep in mind which mass this object has. So if it's too heavy, you see under the rigid body, it falls through. If it's not too heavy, it's exactly on the surface, and it swims along here on the surface, and it can interact with your whole simulation. Yeah, if you want to see more, I have to finish. I'm in the marketplace at the Pixel Train booth. I think some people know, at the coffee bar. I'm here for the full week, so I'm happy if you visit me and we can talk a little bit nerdy stuff, and I hope you've seen something about simulations. Thank you.